Today we're going to start Chapter 7, and Chapter 7 is all about probability. Probability is very important because probability helps us evaluate risk, and evaluating risk can help us make good decisions. But before we get started with probability, we need to set up the framework within which we're going to be talking about probability, which is in terms of set notation and set theory. All right, so there's first of all some vocabulary that we need to learn. So let's go ahead and look at example 1. This is just about as simple an example as you can get. Let's say I flip a coin. What are all the possible outcomes of this experiment? All right. Well, I've already introduced some terminology here, outcomes and experiment, but you don't even have to know what those mean precisely to answer this question, right? You know, we're going to flip a coin and it's either going to come up heads or it's going to come up tails. Okay. So what is an outcome? An outcome is just the result of an experiment. What is an experiment? It's just an activity with observable results. All right. So our activity here is flipping a coin. That's our experiment. And our outcomes are either heads or tails. Now, a lot of times we can just write H or T because, you know, that's easier. And mathematicians don't like to do a lot of writings. They like lots of notation and shorthand. So we can use H and T. That's fine. All right. Next question. What is a sample space of this experiment? Okay, what is a sample space? First of all, the sample space is the set of all possible outcomes. Okay, it's the universal set for the experiment. So all the possible outcomes. All right, so what are all the possible outcomes for this experiment? All right, we're going to write it as a set. It's the set of all possible outcomes, so it's just heads or tails. Okay, those are all the possible outcomes, right? Now we can also just write it, you know, probably more commonly you're just going to see it H and T because that's easier to write. So a sample point is one element of the sample space. So that's just one of the outcomes. Okay, that's called a sample point. What is the probability that the outcome of this experiment of flipping a coin is heads? Well, I bet you know the answer to this too. We haven't even talked about probability yet, but I bet you know it's 1/2, right? It's one of two equally likely outcomes. So so the probability is 1/2. All right. What is probability? It's the measure of the likelihood of an event, right? The likelihood that an event will occur. And an event is a subset of the sample space of an experiment, okay? So we're defining an event as a subset of a set that we've called, we were calling the sample space, okay? So we're defining everything in terms of sets. What are all the possible events of this experiment? All right, well, we've defined event, the term event, as being a subset of the sample space, right? And our sample space, maybe I should have that up here, our sample space is heads or tails. So what we're really asking is, what are all the possible subsets of the sample space? So all possible subsets of the sample space, okay, of S. I could say of S. All right, so let's list all the possible subsets. Now, we did this in 6.1. We looked at all we looked at all the subsets of a set. So we know that the empty set is a subset of any set. We've got the one element sets. So heads would be a subset of the sample space. Tails would be a subset of the sample space. And also, heads comma tails is a subset of the sample space. All right, so that's, you know, just by the definition of subsets, those are all the subsets of the sample space. But let's think of it in terms of our experiment, flipping a coin. What do those mean? Well, I think there's a couple of them that are pretty obvious. Obviously, the subset H is the event that we get a heads. And then the subset tails, right? That's the event that we get a tails. Now, what does H comma T mean? What is that subset? What does that event represent? So that is the event that we get either heads or tails. And of course, we're either going to get heads or tails, so we can consider that the certain event, right? So heads or tails, it's definitely going to be one of those. Now, what about this one, the empty set? Now, that's the event that we get neither heads or tails. Now, that's a strange event to consider, but that would be the impossible event, right? I mean, you're going to get something. You flip a coin, I mean, just logically, you're going to it's going to land on either heads or tails. But that's essentially how we would interpret all of those subsets, all of those events that are the subsets of the sample space. All right, so that takes care of that example. And the next thing we're going to do is look at how we can use some of the concepts of set theory that we learned in Chapter 6 and apply it to probability.